Welcome to Differential Equations, section 6.2. We're doing activity 621. So in this activity, we're going to do a lot of Laplace transform practice, where it doesn't really help us that much. And then in activity 622, we're going to show you how it actually helps you solve things you couldn't solve before. So here we are. We have this differential equation, x double prime plus 4x prime minus 21x equals 2 e to the 4t. So we're going to take the Laplace transform of both sides. So Laplace transform both sides. Of 2 e to the 4t. Now, at this point, remember the table right under section 614 in your book? Feel free to use that. Ain't nobody got time to do Laplace transform from scratch every day, you know? Once you've done it, we trust you. You can use the table now. Okay, so the way this works is that this term, Laplace transform of x double prime, is going to be s squared times big X, which is just the Laplace transform of little x, of s minus s times x of 0, little x of 0, minus x prime of 0, plus 4 times s times big X of s, minus x naught to 0, minus 21, do here, minus 21 big X equals, now, looking at my table, I have an e to the 4t, and the 2 is just, stays. So e to the 4t, that's 1 over s minus 4. And so because there's a 2 there, 2 over, so the 2 gives you that. And then e to the 4t, look up the table, it's 1 over s minus a. Here, my a is 4. S minus 4. All right. Now we really need to simplify this. So fill in our x of 0 and x prime of 0. So x prime of 0 is 0, so we can just forget about that term, which is fantastic. And then that's just 1. So I've got s squared times x minus 1 plus 4 s times x minus 4 times 1 is 4 minus 21x equals 2 over s minus 4. Okay, so then we want to solve for big X. Now, let's see. So then you got the move everything over. So then add the, so I've got s squared plus 4s minus 21 times x equals 2 over s minus 4. That's minus 5, so add it over is plus 5. Okay, so then x equals 2 over s minus 4. And if you don't mind, I'm just going to factor this right from the get-go. So that's a plus 7 minus 3. s plus 7, s minus 3, plus 5 times s plus 7, s minus 3. All right, so now it's time for partial fractions fun. So if I combine these terms, if I combine these terms, I'll only have to do partial fractions once. So at least there would be that, even if it's larger partial fractions. So the one I'm missing is s minus 4. So let's just multiply top and bottom by s minus 4 here. Okay, so that means x equals 5s. This is minus 20, but plus 2, so minus 18 over s minus 4, s plus 7, s minus 3. Okay, so this is equal to a over s minus 4 plus b over s plus 7 plus c over s minus 3. It's all about figuring out what those numbers are. So the algebra just keeps coming. All right, so that means that, forget about that for now. Just try to solve for a, b, and c. So 5s minus 18 equals a times s plus 7 times s minus 3 plus b times s minus 4, s minus 3, plus c times s minus 4, s plus 7. Okay, so 5s minus 18 equals, what are my s squared terms? A, b, and c. A plus b plus c s squared. Okay, what are my regular s terms? So my regular s terms are, I have 7 minus 3 is 4a, and then negative 4 minus 3 is, so negative 7b, and then negative 4 plus 7 is plus 3c s. And then what are my terms without s? Well, that's negative 21a, and then positive 12b, and then a minus 28c. Okay, well, that creates some fun algebra. I'm going to take pause over here, put this all on Sage, and get back to you. Okay, after looking at Sage, I found that A is 2/11, B is negative 53 over 110, and C is positive 3/10. Okay, so that gives us that big X equals 2/11 times 1 over s minus 4 minus 53 over 110 times 1 over s plus 7 plus 3 over 10 times 1 over s minus 3. Okay, well, Then we will take the inverse Laplace transform. So then I've got a bunch of 1 over s minus a's. So that means little x equals 2/11 times e to the, so s minus something means positive a. So s to the 4t. So minus 53 over, that's 110. 53 over 110 times e to the negative 7t plus 3/10 times e to the positive 3t. And that's it. That completes this activity.